All right. Hello, everyone. Welcome back to another segment or another session of Mr. D's math class. This time we're going to be moving on and we're going to study the 2.4 Exponent Laws Part 1. And it has two parts in it, actually. One is understanding the product law, and the other one is understanding the quotient law. Okay. And we will begin with the product law. Um, uh, there's really no way to show you by example, but the one thing you understand about multiplying is it really doesn't matter what order you multiply. Okay, so um, let's have a look at what happens in a data table. Let's try to organize a data table so you can observe what's going on here. Um, let's make a table like this, and again, these examples are actually from the textbook, so I'm just duplicating it in case you rather view it as a video. Okay, so in this column, let's say we're multiplying powers. So we're going to call it the product of powers. And you'll see in the example that I'm going to give you. So it titles itself. Then we're going to write this as a repeated multiplication. Okay. And this is just deriving how the law came about. Okay. And then we're going to, in the last column, we're going to rewrite it as a power, rewriting it as a power. Okay. So let's say you're multiplying two powers. Let's say 5 to the 4, and you're multiplying it to 5 to the 2. Okay, well, what is that going to look like as a repeated multiplication? Well, that's going to look like this. You have 5 to the 4 is equal to 5 times 5 times 5 times 5. Okay, and then you're going to multiply that. Okay, let's just put this in brackets for now. That's 5 to the 4. And 5, and you're going to multiply that with 5 squared, which is actually 5 times 5. Okay, well, if you remove the brackets, okay, really all you have is 5 times 5 times 5 times 5 times 5 times 5, which is multiplying the base 5 6 times. So therefore, if you write that as a power, it's 5 to the 6. So essentially what I want you to observe in this data table is what happened to the exponents here. You have 4 here and you have 2 here, and in the end, you end up with 6. Okay, let's try it again. Let's try it with, let's say, 3 squared multiplied by 3 to the 3. So now I have 3 squared. We'll write that as a repeated multiplication, which is going to be 3 times 3. And then I'm multiplying that by 3 to the 3, which is 3 times 3 times 3. Now, how many base 3's do you have? 1, 2, 3, 4, 5 being multiplied. And therefore, your new power rewritten would be 3 to the power of 5. Do you see the pattern now? Okay. And some of you might already know this, but really all you're doing is when you're multiplying the powers of the same base, you're really just adding up the exponents. 2 plus 3 here is 5. 4 plus 2 here is 6. Okay. And so that's what the product law is. Okay. So that's what we're going to write down next. Let's make some room here. Product law states that when multiplying powers of the same base, of the same base, and this is key here, the base has to be the same. Okay, notice here it's both 3 and 3. In this example, they're both 5. Okay, so the bases have to be the same. Okay, when you're multiplying powers of the same base, you simply just add the exponents. That's the product law. It has a general formula, let's say you have a to the m, multiplying it by a to the n. This is equal to a to the m plus n, where a is an integer, okay, and m and n are whole numbers. Yeah, in your grade 9 math curriculum, they want to stay away from the negative exponents, but I could also teach you that a little bit later, maybe as another segment. It's not very difficult, okay? Yeah, so we'll talk about negative exponents maybe later as a side lesson. So let's try some examples. Another example besides the one that we have up here already. Let's say you want to rewrite this. What is 2 to the 2 multiplied by 2 to, let's say, 7? Okay. Well, you simply just add the exponents. So if you had an extra step here, this would be 2 to the 2 plus 7, which gives you 2 to the 9. Okay. Okay. So let's see if we can derive the quotient law now. Okay. Oh, by the way, here, let me give you another example here because I've already seen some mistakes and people trying to work ahead here. So I might as well make a note of this. Let's say you have 4 times 4 to the power of 3. Okay. What is the exponent here? What is the exponent for this 4? Okay. It can't be a 0 because if it's 4 to the 0, then this would be equal to 1, not 4. In this case, if you did this in the first assignment 2.1, this exponent is actually 1. It's an invisible one, but I think I pointed that out, but you can't see it right now. But if it's not written, it's immediately assumed that it's a 1. So this is actually 4 to the 1 times 4 to the 3. There's your extra step that I want to show you. So apply the product law for this. This would be 4 to the 1 plus 3, and it'll be 4 to the 4. Okay? So just because there's no exponent there doesn't mean it's a 0. Okay, if it is a 0, they'll have to be explicit that it's a 0 there. It's not. It's actually a 1. Okay, so let's try to derive the quotient law now so we won't have this video going too long. Quotient law looks a little something like this. So if you observe again what's the pattern in this table, so let's say when the dividing powers of the same base, 5 to the 4 divided by 5 to the 2, well, how do we write this as a repeated multiplication? This will then be equal to 5 times 5 times 5 times 5. And remember, you can write division as a fraction. So this is going to look like a fraction with 5 to the 4 is a denominator up here. And then 5 to the 5 times 5, 5 times 5, or 5 squared would be in the bottom. And for those of you who didn't know this in math, in fractions, if you have the same numerator and denominator in the top, you can actually cancel those because 5 divided by 5 is equal to 1, so you can cancel that. And then 5 divided by 5 again, that is equal to 1, so you can cancel that. Cancel, quote, quote. And then what do you have left? You have now only 5 times 5, which is 5 squared. Did you see what happened to the exponents? Okay, I got 4 here, I got 2 here, and ended up with 2 here. Some of you are probably guessing already. Maybe you subtract the exponents. I don't know. Well, let's try another example then. How about 2 to the 4 divided by 2 squared? Okay. Write that as a repeated multiplication with 2 to the 4 on top, 2 squared in the bottom, cancel the 2's, bottom and top, and you're left with just 2 times 2, which is again 2 squared. Okay, so if you didn't guess already, the product law states that if you're dividing powers of the same base, then you subtract the exponents. That's really all you do. So let's write that out. Quotient law. Quotient law. This is a Q, by the way, Q. Quotient law states that when dividing powers of the same base, and that is key also, it has to be the same base. If you don't have the same base, then you cannot apply this law. Subtract the exponents. Okay? So in general, a to the m now, if you're dividing it to a to the n, this is going to be equal to a to the m minus n, where a is an integer, other than 0, because you can't have a 0 base, and then m and n again are whole numbers. So it's basically almost the same as the product law, except this time you're subtracting instead of adding. Okay. Now let's try an example. Let's say -9 is a base to the power of 10 divided by -9 to the power of 6. What do you do with the exponent? According to the product law, according to the quotient law, you subtract the exponent. So this is -9 to the power of 10 minus 6, which will give you -9 to the power of 4. Hope it's quite easy. Hopefully it's straightforward. Okay. Again, let's try one with the exponent is not explicit. Okay, invisible one. So let's say you have, let's say negative. No, let's keep this as. Let's keep it simple. Let's keep it as. There's an example. Okay, let's make it a -3. -3 to the power of 5 divided by -3. Okay, again, no exponent written here, but this is not a 0. Okay, this is actually a 1. There's an invisible 1 there. So this would be -3 to the power of 5 minus 1. And -3 to the power of 4. Now, I'm not evaluating any of this. I mean, if it asks you to evaluate, and then, if it asks you to evaluate, then you will have to, type this in your calculator and find out what it is, okay? And actually calculate it. So this is -3 times -3. This is as a repeated multiplication, but in your calculator, -3 to the 4 will be this +9 times +9 will be +81, okay? So you might be asked to do that much also. I hope this helps. I don't want to make this video too long, so again, make sure you view these videos and help guide you. If you have any questions, then we'll have our bringing your questions to the Google Meet, or you can email me. Thank you so much. Bye-bye for now.